Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0443, indicates a malfunction in the EVAP Canister Purge valve circuit, relevant for Honda Civics manufactured from 2016 to 2021. This component plays a pivotal role in the vehicle's emissions control system by allowing the engine to draw in fuel vapors from the EVAP canister during normal operation. The EVAP, Evaporative Emission Control, system is essential for capturing and reusing fuel vapors that naturally occur in the fuel system, thus preventing them from escaping into the atmosphere. The EVAP Canister Purge valve is typically located in the engine compartment and has connections to both the canister and the engine's intake system. A malfunction in this valve can affect vehicle performance and emissions, potentially leading to increased hydrocarbon emissions. The presence of the P0443 code indicates a significant issue within this system, prompting immediate troubleshooting to identify the underlying causes and rectify them efficiently. DTC P0443 signifies that the EVAP canister purge valve circuit is malfunctioning. This valve is crucial in controlling the expulsion of fuel vapors from the EVAP system to the engine for combustion. The EVAP system's primary role is to reduce vehicle emissions by managing these vapors. When the purge valve fails, it can either remain open or closed, resulting in improper vapor flow. Of note, this valve is usually positioned within the engine compartment, making it accessible for diagnostics. By regulating the amount of vapor reaching the engine, the purge valve optimizes fuel efficiency and minimizes pollution, highlighting its critical role in both performance and environmental impact. Several possible causes can lead to the emergence of DTC P0443. One common cause is the EVAP canister purge valve becoming stuck in the open position, continuously allowing vapor flow when it should not. Conversely, if the purge valve is stuck closed, it can prevent necessary vapor flow altogether, causing disruptions in the emission process. Another potential issue could be faulty wiring between the purge valve and the powertrain control module, PCM, which can hinder signal transmission and proper operation. Additionally, a blown fuse could also lead to the malfunction of this circuit. These possibilities emphasize the importance of thorough diagnostics to determine the specific fault affecting the purge valve circuit. Symptoms associated with DTC P0443 may manifest in several noticeable ways. The most immediate indicator is the illumination of the check engine light, CEL, on the dashboard, alerting drivers to the issue. Additionally, drivers might experience poor engine performance due to improper fuel vapor management, leading to stalling or rough idling. Increased vehicle emissions are a significant concern as well. A malfunctioning purge valve can push unregulated vapors into the atmosphere when they would otherwise be contained. Lastly, drivers might observe diminished fuel efficiency, as the engine could be inefficiently using fuel vapor, thereby leading to higher consumption and costs. These symptoms collectively serve as critical indicators for technicians to investigate the integrity of the EVAP system. The first step in troubleshooting DTC P0443 is to confirm the existence of the code and gather appropriate initial data. Begin by turning the vehicle to the on mode without starting the engine. This allows for the initialization of onboard systems and prepares them for diagnostics. Next, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. Once cleared, start the engine and allow it to idle, maintaining an engine speed of 3,000 RPM. The vehicle should be either in park or neutral if it has a continuously variable transmission, CVT, or in neutral if it has a manual transmission. The intent here is to trigger the system adequately. After this process, check whether the DTC reappears as either pending or confirmed. If DTC P0443 is indicated, the failure has been duplicated, and you can proceed to the next troubleshooting step. In the second troubleshooting step, the focus shifts to diagnosing the EVAP Canister Purge valve directly. Start by turning the vehicle off and allowing the engine to cool below 131 degrees Fahrenheit, 55 degrees Celsius. For safety, once cooled, remove the EVAP Canister Purge valve, ensuring that the connector and vacuum hose remain connected to facilitate testing. After this, disconnect the vacuum hose from the valve and attach a vacuum pump or gauge calibrated to read between 0 and 30 inches of mercury. After connecting the gauge, start the engine and let it idle to read the vacuum level. If there is noticeable vacuum, it indicates that the EVAP Canister Purge valve is stuck open, revealing one possible fault. In contrast, if there's no vacuum, it suggests the valve is stuck closed. Each result directs the technician towards the appropriate next step for further diagnostics. Step 3 involves checking continuity through the purge valve connector, which assists in identifying electrical issues. Start by turning the vehicle to the off mode for safety. Disconnect the 2P connector from the EVAP Canister Purge valve to isolate it for testing. With the connector removed, check for continuity between the designated test points within the connector. It's crucial to measure continuity under the vehicle off condition, as it reduces the chance of erroneous readings caused by voltage in the circuit. Test point 1, located on the female terminal number 1 of the connector, should have a continuity path to body ground at test point 2. If continuity exists, this confirms that part of the circuit is functioning, allowing you to progress to step 4 of troubleshooting. If continuity is absent, it indicates that the purge valve requires replacement due to internal failure. In the 4th step, the emphasis is on checking for any shorts in the IPV, intake vapor pressure wire. First, utilize the HDS to jump the SCS service check short line, allowing a short delay of more than 1 minute for the system to stabilize. Subsequently, disconnect the PCM Powertrain Control Module Connector E, specifically the ADP configuration, to secure a proper testing environment. With the PCM connector disconnected, check for continuity between the specified test points. Test point 1 connects to the female terminal number 1 of the EVAP Canister Purge valve connector, while test point 2 connects to body ground. If continuity is present, it indicates a potential wiring fault causing a short in the IPV line. In such a case, corrective actions should be taken to repair the short. If continuity is not detected, the IPV wire remains intact, suggesting more exploration into whether the DTC is tied to the PCM itself. Step 5 involves evaluating the voltage present in the IPV line to ascertain circuit integrity. Begin by powering down the vehicle, ensuring it is in the off lock mode. Disconnect the EVAP Canister Purge valve 2P connector, isolating its influence during testing. Once isolated, power the vehicle back up to on mode, which allows you to measure the voltage present at the connector. Checking the voltage between the designated test points will determine if battery voltage is being supplied correctly. If battery voltage is detected, it indicates that the IGPS ignition power supply wire is functioning as expected, allowing you to progress to further diagnostics. However, should voltage be absent, investigate the number A11 5A fuse located in the underhood fuse relay box for any signs of being blown. If the fuse is compromised, it must be replaced, and a potential short to ground checked in its circuit. If it's intact, then an open in the IGPS wire between the purge valve and the fuse must be inspected. The 6th step focuses once again on the IPV line, but checks for potential open circuits. As previously done, Begin by setting the vehicle to off mode for safety. Use the HDS to jump the SCS line, waiting for over 1 minute to stabilize the system. Next, disconnect the PCM connector E, ADP, to segregate active circuits and minimize interference during testing. This step requires checking the continuity between test point 1, which connects to the EVAP Canister Purge valve's female terminal number 1, and test point 2, running to the PCM connector E's number 80 terminal. If continuity is detected at this stage, the IPV wire is confirmed to be functioning correctly. However, if continuity fails, it suggests an open circuit in the IPV wire between the PCM and the EVAP Canister Purge valve, thus necessitating appropriate repairs. The final troubleshooting step assesses the internal resistance of the EVAP Canister Purge valve itself. As with previous steps, ensure that the vehicle is in the off mode to guarantee safety during measurements. With the EVAP Canister Purge valve's connector still disconnected, utilize a multimeter to measure the resistance between the two designated test points within the valve itself. Under normal conditions, the resistance value should fall between 23 to 26 ohms at room temperature. If the measured resistance aligns with this range, it implies that the EVAP Canister Purge valve is functioning correctly and is not the source of the DTC P0443. Should the resistance deviate from this standard, the purge valve must be replaced, as it fails to meet the operational requirements, thereby contributing to the malfunction indicated by the DTC. After completing the necessary repairs or replacements, it is crucial to conduct a final verification to ensure that the issue has been resolved. Utilize the Honda Diagnostic System, HDS, to recheck for any existing DTCs. A clean bill of health, indicated by the absence of DTC P0443 or any other trouble codes, validates that the repair was effective. After confirming no faults are present, take the vehicle for a test drive under various operational conditions to gauge performance. Observing smooth operation without any check engine light activation during the drive further substantiates the success of the repairs done to the EVAP system. This step is integral not only for customer reassurance, but also for maintaining stringent emission control standards. To prevent future occurrences of DTC P0443 or other related issues, implementing a rigorous preventive maintenance schedule is recommended. Routine checks of the EVAP system can help catch any potential faults before they escalate into more significant problems. Regularly inspect the connections and wiring associated with the EVAP Canister Purge valve to ensure they are secure and free from corrosion or damage. It is also beneficial to replace any aged components proactively, as wear and tear can adversely affect the performance of the vehicle's emission control systems. By maintaining vigilance with these practices, vehicle owners can prolong the life of the EVAP system and enhance overall vehicle performance and compliance with emission regulations. In conclusion, DTC P0443 for the EVAP Canister Purge valve circuit malfunction is a significant error that warrants prompt attention. Understanding the implications of this DTC and the associated components is essential for effective diagnosis and repair. Following the detailed troubleshooting steps methodically allows for accurate identification of issues within the system. Each diagnostic action provides valuable insight into the possible failures impacting valve operation, whether it be mechanical failure, wiring issues, or PCM-related faults. By ensuring proper repairs are executed, vehicle reliability and emissions compliance can be restored, providing a better driving experience and contributing to environmental sustainability. Please like and subscribe to the channel. See you next time.